All right. Hello, everybody who's joined this live, as well as everyone who checks this out via recording on our YouTube channel. So we'll get underway right away because we've got a pretty full hour. And so in terms of who we have today, myself, Steve Fortuna. I think a lot of people know me by now. I work as an SC in EUC in healthcare supporting the country, but we've got some new people with us for this month's webinar. Chris, while Hilco gets its stuff together, would you like to say hello real quick?
Sure. My name's Chris Pointer. I am a senior TAM here at VMware. Spent about 15 years in the healthcare space. Now I'm supporting healthcare customers on the East Coast, and I see a few of my awesome customers in the attendees list.
And speaking of former customers, Sean, would you like to say hello?
Sure. Yep, Sean Miller. So I'm a senior solutions engineer on the healthcare team. Been with VMware for 5 years. Prior to that, I actually came from a healthcare customer where I was there for 8 years, where I actually got to implement and manage both of the EUC products, so Workspace ONE as well as Horizon.
Awesome. And I may be speaking out of turn, but I believe Sean is carrying the heavyweight belt of SE of the year as well. And so what we're going to look to do over the course of this hour, quote unquote, am I in the right meeting? Right. So this is going to be a discussion all about healthcare. This time we're going to be focused on Horizon. Some of you may know we did a Workspace ONE and clinical SSO webinar last month. This time we're going to focus on performance and specifically end user experience. We do no marketing, and we brought in our special guest Hilco, who has a particular amount of experience and insight that I'm personally really excited for the healthcare audience to get to share. And I'll check in with Hilco in just a second, but how are we going to do the session? How's the hour going to unfold? So we basically broke it into 3 parts. So we'll start with Hilco, and he will talk about, OS performance and optimization. What can we do if we do everything we can do to fine tune our gold images? What benefits are we going to derive from which approaches? Tools of the trade from Chris and his personal experience, both as a TAM, as a customer, things that he's seen drive results. And then Chris and I will do the remote experience and performance section, which of course is a lot in a short amount of time, but we're gonna try to zero in on best approaches for both audio and video, understanding the different optimization packs that are out there, talk about some things like RTAV, URL content redirection, the Teams optimization pack, and more. And then we'll bring it back to Hilco, who's going to talk about this very fascinating topic for me personally, the conversation of GPU and healthcare. Do I need to have a GPU? What's our position? Why or why not should we have a GPU? And then at the end, actually, we're not done there because Chris and I talked, and I threw a couple of questions out there for the audience. Would really love our customers' feedback, thoughts, responses before we do our, how to learn more, where we wrap. And so, Hilco, before we turn things over, I'll see were you able to remediate things over there? Would you like to say hi?
Yeah, I think this will work well enough. So yeah, I'm Hilco. I've been doing EUC for over 20 years. Did do a bit of healthcare as well when I was in PSO. And I'm in technical marketing currently. And there we do like the optimization guides, we do the reference architecture, but I also help out a lot with engineering, and I help a lot with the benchmarking team. So that's where I get most of my data. And I work quite closely with Login VSI on their new product, Login Enterprise, which is what I use to get most of the data. See you shared again. Can you see my screen?
You are good. She's all yours.
Yeah, so the only, let me explain the problem then as well. So I have a MacBook and it overheats when there's things connected to both sides. So I could only attach one monitor, which means I do not have my speaker notes. So it's going to be interesting. It's like a quiz for me. How well do I know my own slides? But yeah, so one of the things I said is we write like the optimization guide. I also worked on the VMware OS optimization tool for quite a long time. And the basic flow, what we have in the optimization tool is that we do an optimize, which is where we apply all of the settings which are beneficial. So we could trim down like the background or turn off sounds, shut down certain services. Then we have a generalized phase. This is where we run sysprep and we do a copy profile of the default user to the basically of the administrator to the default user. And then after that, we have a finalized phase. And in the finalized phase, that's where we do disk cleaning tasks and chores like that. And we will see the benefits of OSOP later on. Now, before we go into the benefits of the VMware OS optimization tool, we're going to talk a lot about CPU. So it's important that we understand the charts, but also it's important that we understand like the technologies involved. So in this example, I took AMD EPYC. And what you see here on the sheet is that it has a base clock of 2.8 gigahertz. Now factually, and you see a max boost clock of 3.7 gigahertz. But factually, when we talk about VDI or RDSH, we're not interested in the base clock nor in the max boost clock. What we're interested in is the all-core turbo frequency. So know that for the AMD EPYC 7543, it's 3.5 gigahertz, but that is the number that actually matters. That's when everything is running, everything is at its maximum state. That's the actual frequency that we get. To be able to get that, it is important that we are allowed to scale up in frequency. So there's two technologies for power management. One is called P states, the other one is called C states. And the C states are the states below the base clock, and that is to reduce power. And the P states are the performance states above it, or also called turbo. So those are the various turbo amounts. And the more you use, the lower the turbo frequency gets. So when on the AMD EPYC, if you only use 1 or 2 cores, it's 3.7 gigahertz. And then it keeps going down. And in this case, it only goes down to 3.5, but it's the 3.5 that matters. Now, what I also wanted to show is the importance of that turbo and to have it up and running. And I also wanted to talk a little bit about SMT or hyperthreading. So when we just look at the base clock of this CPU, if we would take that as 100% of the performance, if we set the energy states correctly and we have the turbo, we actually get a gain of 18, 19%. For some CPUs, it's a lot higher. It could be even 40, 50%. And then when we add hyperthreading on top of that, depending on the CPU, you get a gain of another 20 to 40%. Now, the actual frequency hop from 2.8 to 3.5 gigahertz is much higher than that 18% that you're seeing here. But whenever a CPU is quicker, tasks are also executed quicker. So there's a little bit of the performance going into density, and there's a bit of the performance going into the actual performance of the individual VMs. So that's important to keep in mind. Now, when you look inside vSphere, on the default overview page, it will show you the usage of a CPU. And the usage of a CPU, that is how much it is using of its nominal frequency. And that means that in this graph right here, you can see that it goes to 100% quite quickly, but it doesn't account for the turbo speeds, and it also doesn't account for the turbo plus SMT speeds. Now that's the other two charts that you see in here. So the blue line is the core utilization, that is the turbo frequency, and then the purplish line, that is actually the turbo plus HT. And that's also the only number that I usually look at. It's the utilization that really matters. Then when you look at anything inside vSphere and you look at CPU usage, there is a 20-second interval. And that means that you're getting an average over 20 seconds. Now, if you go with SSH into the ESX host itself, you get a 2-second interval, and it's already showing you a lot more resolution in there. But factually, a CPU only has 2 states. It's either executing something or it's not executing. So if we could get enough resolution, if we would zoom in far enough, the only thing you would be able to see is like a barcode, right? There either is a bar or there's no bar, and the thickness of the bar would describe how long it has been executing something. So the other place to look in vSphere would be on a VM. And on the VM, there's two interesting charts. So there's like an entitlement, that's how much it has got, and there's a demand. And the demand is basically the VM asking for execution time to the scheduler. And what we want to see if we look at a VM is that the demand and the entitlement stay reasonably close. So it doesn't matter if you have a little bit more demand than the system is actually entitled to, a task would just take a little bit longer. But if the difference gets too big, then the task is taking so long that for an end user, it's noticeable. And if you look like tools like Login VSI, which is a benchmarking tool, or Login Enterprise, and if you see what they do, is they basically watch where a task is taking around 1 second longer than it took when there was no congestion. And they say that roughly when it gets around a second, user starts to complain. So that's where the system is saturated. So back to the OS optimization tool. So why do we optimize? Well, here's a chart from vSphere, which actually shows you the CPU usage across time. I think these were, I don't have a speaker notes, but I think it was like the first 55 minutes. So all you're seeing here is a log on and then an empty desktop just waiting around. And what you can see, I think there's you have the logon process first, which is taking up quite a lot. Then there's a bit of time where nothing is happening. And then you get into the either delayed start services or the actual scheduled tasks. And what you can see here is that they do take up quite a lot. I mean, this CPU, as I told you before, is like a 3.5 gigahertz CPU. And it is taking like a full core, but then for half an interval. Now, if we do the exact same thing on an optimized VM, we see the same graph. We also see it picking up to roughly 5 gigahertz. I mean, that's the same, but it's in a much shorter duration. And you can see that everything is just a lot slimmer. There hardly are any scheduled tasks left, and it's just doing less. Now, when we combine the two graphs, or we put them, oh, it'd be nice to go back. If we put them next to each other, what you can see is that everything was quicker. I mean, the log on just was enormously quicker, but you can also see that the CPU is way less busy. Now, when we run multiple VMs, those VMs, when they're sharing the same cores, so firstly, you've got multiple cores, right? So every VM that you execute will get their own cores to run on, but there's a certain point in time that all cores are taken, and then VMs start to share cores. So what you need to imagine is that other VMs are going to be in the same graph. And it's quite easy to spot that in the green, you can fit a lot more VMs on the system than in the yellow. With the yellow, it would be much more crowded soon than in the green. And that's one of the main reasons why we do the optimization. It's to get a higher density. And then the other thing that you can clearly see in this graph is to get things done quicker. So the log on is actually happening quicker. We're sending less data because we're turning things off like the background, or we're turning off animation. So there's less data being sent out to the actual clients. Another question I get asked a lot is, what operating system should I use? And earlier, let's say before Windows 1809, there was a huge variance in the performance of the individual editions of Windows. But since Windows 1809, everything after that, it's all roughly doing the same thing. So what I did here is on the left, you see the average usage in megahertz. This is for just a knowledge worker. And then I threw a purple line across with the average. And what you can see here is that they're all roughly doing the same thing. And there is a run-to-run variance. It's quite consistent like this, but it's only taking a couple percent more or a couple percent less. So by now, it doesn't really matter if you use Windows Server or you use Windows 11 or you use Windows 10 20H2. It's all the same. But talking about Windows 11, what does really matter is the features that you use within it. So when we turn on vTPM, and as you probably all know, TPM is required with Windows 11 to run, there's a slight incline. It's just a couple percent, not too bad. But if you go into like the security features of Windows 11, so you use virtualization-based security, secure boot, you turn everything else on, we're talking about at least a 10% bump. So Steve, do we have any questions in the chat that need answering?
I think we're clean right now, and I probably should have mentioned that when we were doing the session overview. We want to definitely heavily encourage anyone to ask any questions in the chat they may have. There are no stupid questions, and we won't always have Hilco available to a healthcare audience on a webinar. So even if you have something specific to the topic or maybe on the periphery, by all means, feel encouraged to use the Q&A.
Okay, so when we talk about the number of vCPUs you should be assigning, there has been a lot written, and some of those were based on the wrong assumption. So let me rephrase that. When Login.VSI did their testing of Windows 10, they concluded that you need 2 vCPUs to run Windows 10. And the way that Login.VSI works is they run benchmarks on the VMs, and they keep adding VMs over time. So, and then they take the lowest 15 VMs, so the best performing 15 VMs from there, they deduct the 2 fastest, so they take the 13 that are left, and that is what they call their baseline score. And then every task that's being executed executes in a number of milliseconds. And as soon as they keep adding VMs, as soon as those tasks take a second more, they say, okay, the system is saturated. Now, the problem there is that the first 15 VMs, they might get higher turbos if you do not put the system into high performance. So that's one variance that's in there. Then the other thing is that at that point in time, you're not sharing those cores. Those 15 systems will be the only ones that are using cores, and they have another performance line than anything that comes after it. So let's just say that you assign 2 vCPUs to every VM. That first 15 machines actually have extra power because they will get 2 times 3.5 gigahertz, so they have a 7 gigahertz total. But when you get to higher densities, when you do a 1:7 ratio on the vCPUs to the physical cores, it's no longer that. Then we're talking about, are you giving the system 1 times 800 megahertz, or are you giving them 2 times 400 megahertz? I mean, they're all the same. It's the same thing. The only advantage of having a single CPU, a vCPU, is that there's no wait time involved. So when we have multiple vCPUs, we schedule them in the scheduler. And within the scheduler, what's actually happening is we've got something called relaxed co-scheduling. And that means if only one CPU needs to execute anything, there's nothing for the other, it only runs on one, so the other one keeps free. But then you get a time drift between those two. So we have a method called co-stop, which is just done for them to be able to catch up. But there is like a penalty involved. The other thing is that not everything shares well across 2 CPUs. So one CPU basically could be better as long as you stay within the max. So that's what you see in the chart. If we look on the left side, if I take one single vCPU, I'm actually getting 130% of getting 3 vCPUs. So it's performing better. And then in the middle, you're seeing an average grade from 1 to 10. And that is so that's not the density, but the actual performance. So this is an end user experience score is the highest with 1 vCPU. Now, does that mean that you should run everything with 1 vCPU? No, it definitely doesn't. What this means is that as long as your workload is performing within the boundaries of 1 vCPU, so it's not getting beyond that. So when it peaks up, it's not peaking beyond 3.5 gigahertz, or not really. It will be best to do 1 vCPU. But if you're doing intensive tasks, then of course you need to use multiple vCPUs. But then on top of that, you need to keep in the back of your head that you cannot share those CPUs as much. or you're not giving them any extra power. With the example like 1 times 800 or 2 times 400, they're not getting anything extra. They need more, so you share the cores less. Now that we're on the topic of AMD EPYC specifically, and also the newer Intel CPUs, the other thing to keep in mind is how the physical CPU is working and what it is doing in the background. So when I buy a 32-core AMD EPYC CPU, it actually isn't a 32-core CPU. If you would take the lid off and if you look inside, what you will see is that there's 8 dies inside, or actually 9 if you include the cache and the I/O, but there's 8 CPU dies, and they all have 4 cores each. And all of those packages with 4 cores have their own level 3 or last level cache. So factually what you're buying is not one 32-core, but you're buying 8 4-core CPUs. Now, why that matters is the actual amount of cycles it takes to get somewhere. So if I want to fetch something from the level 1 cache, which is internal in every single core, it takes 4 cycles. The L2 cache is a little bit slower, it takes 13. And the L3 takes 35. But when you then go to RAM or you need to go up, it just keeps going up. And that means that if anything is running and it now moves to a different CPU and I try to do an instruction, it could have been in the local L3 cache in the green in this diagram. But if I move to the pink, then it's no longer there. And then instead of using 35 cycles, I will be using 400 cycles to fetch it again from RAM. So keep that in mind. The other thing that is important is how well does something fit. So if I just go back one slide, and if we are now aware that we have basically have 8 4-core CPUs, if I try to deploy VMs and they have 3 cores, it's not going to fit that well, because it would mean that I'm either taking up 75% and then the next one is going to take 1 and then 2 on the next one, which are not sharing the same L3 cache, but it's not a nice match. So to keep in mind is like the divisors. So through what number can we divide it and we would still have a clean division? Now for that example with the 32 core, it would be 1, 2, and 4. And for a 64 core, which has 8 cores per domain, it will be 1, 2, 4, and 8. And if we now go back one more slide, and if we look here, we can actually see that in here. So what you're seeing here is that with 4 vCPUs, I'm actually getting a slightly better density than with 3 vCPUs, which doesn't really make sense. But the reason for that is that the hypervisor is able to schedule it very, very well. So that's what I wanted to say for AMD EPYC specifically. Think about the actual thing that you're buying. It could have 3 vCPUs per subcomponent, it could have 4, it could have 8, but try to stay within that. Then if we're not talking about VDI, but talking about RDSH, you can do multiples of the divisors. So a desktop operating system only supports 2 sockets. And that means that you could use 2 of those dies, whereas with server operating systems, you could do multiple, because there we support multiple sockets. Now the reason, that's the next slide, so I'll come there later. So then, now that we're on the subject of cache, when you buy a CPU, it's also important to have a peek at the amount of cache of the CPU. So here I took an example where it has either 4 megabytes or 8 megabytes cache per die. And what I did is I turned off certain dies within the BIOS. But what you can actually see is that you get an 18% uplift with more cache. Now, the reason why the cache also matters is because the guest operating system is making decisions on what to execute where. And when we stay within the number of cores per socket, what you can actually see is that the guest operating system is aware of the underlying topology and what's able to work together. one more slide on this one. I'll skip over this one. So to be able to use the correct cache setting, what you need is the correct hardware level as well. So here I've got two examples. So if I create a VM on the right and I set the hardware level to 15, which equates to 67U2, what you can see for this one, I did, let's see, I did 2 vCPUs. I did them in a single socket. And if we now look under the logical processor to cache map, what you can see there is that we have 2 level 3 caches. So, and it says 2 times 256 megs. And that means that if the guest operating system is reading this, it's actually thinking, okay, I've got 2 vCPUs, but nothing can work together on those CPUs because they're not sharing the same cache. If I use hardware level 19, which is cache aware, and I set the topology correctly, then what you will see is that it knows that it's actually sharing 132 meg of cache, and then the guest operating system knows that they can work together. And this is why it matters to set the cores per socket correctly. So earlier than vSphere 7U2, we always said like, well, cores per socket doesn't really matter. You just need to be aware of the limits of the desktop guest operating system. But now it does. And what we actually do with the cores per socket is that you set it equal to the number of vCPUs when the number of vCPUs is equal or smaller than your cache domain. And then when you get above it, it would be equal to the cores per cache domain. So in our example, with the 32 core CPU, the number would be 4. So every 4 cores are sharing a per cache domain. And that means if I'm doing 1, 2, 3, or 4, I set the cores per socket equal to vCPU. And then when I get above it, I actually do the cores per socket equal to the cache domain, so 4. So with 8 vCPUs, the number would be 2 cache domains that we end up with. This one. Okay. So Steve, I think this is your section again.
Yeah, great stuff, Hilko. I feel like I'm watching a VCDX defense. So all right, your screen sharing is done. Give me 1 second. So Chris, all right, we're gonna get after this here now. Chris and I were laughing at watching meetings where we have to say next slide, please. So this is going to be Chris's part, but then we'll get on to the remote experience. There we go. All right, we're good. You ready to do it, Chris?
Go for it.
Let's go for it. It's all yours. All right.
So we just talked about OS optimization, right? Hilko went into great depth there. Great tool. It's really developed a lot over the years, but you need to go a step further when you're looking at what you have running inside of your Horizon sessions. Steve and I always joke that being a Horizon admin is like being an expert in all of the technologies. You got to be a load balancer person. You got to be a server person, a desktop person. You got to understand it all. One of the parts you have to understand are the apps that you have running. If you're looking at troubleshooting issues, troubleshooting performance, trying to optimize and tune, you need to understand what the application is doing. There's a couple of great tools for that. One of my favorite is Process Monitor. So, free tool from Microsoft. It's been around for decades, right? I've been using some flavor of these tools since the early 2000s. Process Monitor will let you inventory what processes are happening on your system. The key with Process Monitor is learning how to use filters. You will be inundated with data when you kick off Process Monitor. So you need to start looking at what processes you're looking at, what sessions you're looking at, things of that nature. Another great feature of it is boot logging. So you can set your VDI or RDSH app. If you're having slow startup speeds, you can set it to log what processes are running at boot. So typically areas where you don't have a view into the system. You can have that logged, and then you can play back that log later and then start filtering it out and start looking for things. Great things to look for are what's being read, what's being written. Are you seeing errors in writing registry values? Are you seeing errors writing logs that might be causing timeouts that start to stack? A lot of times as Horizon admins, we look for the one thing that's causing my 20-second slowdown. It's usually not the one thing. It's a lot of things, and you're trimming milliseconds here and there, and you'll get there, right? So Process Monitor, great tool. Next slide, Steve. One step up from that is Process Explorer. So this is a great view of what process has called what other processes. This is kind of the 50,000 foot view, right? If Process Explorer is getting down in the trenches, Process Explorer is looking at what things are running. Great for tackling handle leaks. If you leave it running overnight in a session where you're having some oddball behavior, when the session exists for a long time, you might have a handle leak. This will help you start looking at those details. Another feature, another tool from Microsoft, great thing to have in your toolbox. Next slide, please. Everyone's favorite part of troubleshooting Horizon are GPOs. Do not overlook it. I see a lot of customers look at everything but their Active Directory environment when troubleshooting things that are happening inside of their sessions. A lot of times the Active Directory teams are separate. So there's a little bit of a silo there. Always look at what group policies are being applied to your VDI guest. Always look at where you are in the OU structure. Are you picking up a ton of default domain policies that may not apply to what you're doing? Are you blocking GPOs at a higher level OU that you don't need, right? That's always a great way to look at things as well. Use the GPMC to run models against your target OUs. Understand what policies are coming down, what time is taking. There's a great tech community post on the Microsoft site. You can see that there. Screen capture this link. Does a really good job of going in and troubleshooting group policy. There are some registry values, as you can see here. The GPSVC debug log will give you, again, just an absolute ton of data. Something worth looking at if you're really trying to find what might be happening in your group policy environment. Things that don't always stick out, right? And this is an issue that I've troubleshot before. An organization with a flat domain with multiple branch sites, right? Not using sites and services. Your Horizon sessions may be picking up policies from a DC that is on a latent connection. Very hard to troubleshoot, very hit or miss. Sometimes it's great, sometimes it's slow. These kinds of tools will help you identify that, and then you can start making suggestions and moving it forward, right? Maybe you need to create sites and services. Maybe you need to limit where your Horizon sessions are pulling their policies from. Next slide, please. One of the biggest issues with using these tools is to make sure you've turned them off when you're done. The same with logging, right? If you have your Horizon logs turned up to trace level, all of these things are performance impacting. They will slow your sessions down. Don't forget to turn them off when you put them away and turn them back over to your end users. A lot of times I see things that are left running, left collecting data, and you're causing a little bit more of a problem than you're fixing at this point. So just remember to clean those things up as you're done.
Outstanding. Good work, Chris. All right. So now we'll move right into our remote experience part of our hour. So starting off, we've got devices and we've got distance. We've got no shortage of either in healthcare. So what that means, right? And a lot of people will recognize a schematic like this. Not all users in a healthcare organization are close to where the services are being provided, whether it's distance to the main data centers, regional healthcare facilities, whatever it may be. But what it comes down to start this remote experience conversation is thinking about device redirection and thinking about USB. Quoting a good friend of mine, Andrew Klopp, USBs were designed, a USB cable is designed to run at microseconds, and it's designed to be about 6 feet long, right? And great question Andrew asked rhetorically when we were talking a couple of years back. Do we want to take a 6-foot cable and then run at 60 miles, right? And there's the heart right there of some pain that we've seen with some of our customers in healthcare. All right, so how to do better. So Chris and I were talking about, we've got loads of documentation. We don't have a ton of illustrations. So we tried to do that for the presentation today, of draw out what we mean when we're saying what we're saying. So first, this will be what bad looks like in a lot of cases. So I'm at some distance. I'm a user in a healthcare organization, and I've got a microphone and a webcam, right? So if I were to do USB redirection, I'm going to full on redirect these devices via USB over to the Horizon agent, whether VDI or RDSH. So what's going to happen there? So number one, why is there a red X over on the left? Number one, if you've got a Linux client, thankfully, it's not going to be forwarded, which is probably in many instances a good thing. I talked to some colleagues just to confirm, right? So it will work if you're on a Windows or a Mac client. Your webcam and your microphone will be forwarded to your virtual machine instance. But what are you going to get? Highlighted over here, right? Significant bandwidth consumption. Some would say astronomical. You're not going to get good performance. And if you read our documentation, while the video will technically work, it won't work well. And video is not supported with USB redirection. Okay, so then let's pivot, and what does good look like? So enter real-time audio video. And as you'll see, as we go through this discussion, there's an arc of, okay, we kind of do the baseline of quote unquote bad, we'll get to good, and then we'll get to better. So good, real-time audio video, right? So we'll draw this out. Again, I've got a person somewhere working for a healthcare organization. I've got this microphone and this webcam at my client device. So with real-time audio video, or RTAV, as we may affectionately call it, we're going to keep the devices local. We're not going to do full-on USB redirection and forward those devices. And then we're going to have some compression savings, some bandwidth savings. And then over on the VM side, over here on the top right, we're going to instantiate a virtual microphone and a virtual webcam. That's going to get us some benefits, right? We're going to save bandwidth with audio, definitely with video, and we've got a different topology, and we're offloading some processing that we might not otherwise. So to go back to, well, what did we just see and what did we just do here? All right. So number one, RTAV, or real-time audio video, we're not forwarding the microphone or the audio device and the webcam the way that we would with USB. Second, with the devices left local to the client, we're going to pull the image, we're going to pull that video, we're going to compress it, we're going to encode it, and then we're going to send it optimized over to the virtual machine, where it's going to be decoded and effectively played to that virtual webcam and the virtual microphone. And that's how that flow is going to be different. And so for number one, because we've seen this pain in the field, first question that may come to mind is, are you doing full-on USB redirection? Do we make sure, okay, are we sure that RTAV is in place and USB redirection is not? So working on a baseline for RTAV, where does it work? So it works not only for VDI, but also works for RDSH and published applications. Over on the client side, it works with Windows, it works with Mac, it works with Linux, HTML, in addition to iOS and Android. Keep in mind, you need to get the drivers for your audio and webcam devices over on the client side in order for this to work correctly. Nested mode, right? Coming up more than ever, right? A lot of our customers maybe 5 years ago were all VDI. We have more and more adoption of published applications, therefore more and more adoptions of the double hop or nested mode. RTAV will work with nested mode as well. Now, how to make sure that you're getting the results that you think you're going to get when you make sure that RTAV is up and running and enabled. So the first thing is your Horizon agent, right? So if the Horizon agent is installed with the RTAV feature, then you're good to go. You really don't need to do any further configuration for a real-time audio video to be activated. However, right, so here's the however slide. If you're using a Windows or a Mac client, those USB devices that we don't want to have redirect with USB to redirection could potentially, if they're not explicitly forbidden from appearing on the Horizon client, they could show up in that drop-down menu, as I mentioned before, Linux is going to block it by default. But if you are on a Windows or a Mac device, then you want to make sure, if you can, that those options don't appear in the Horizon client, right? So the best way to do that would be with root policy and the Horizon agent, and we can create some filter rules to make sure, hey, these family of devices we don't want to see appear over on the client side. So please block it on the agent. I'll pause and ask Chris, you're so good with the real life experience and observations. Anything you've seen personally that would be good to mention here?
Yeah, so definitely look at blocking families of devices if you're going down this road. Some of the challenges can be, we've long had the ability to do VidPid blocking by looking up specifics on devices. You can also look at blocking families of devices, which helps, make the blanket a little bit bigger that you're blocking. Also, you may get into a place where sometimes there are epic workflows where you want a webcam, but the video portion of the webcam available for doing things like prescription tracking, or for taking, at the registration desk, for taking pictures of patients to associate with a record. So you can block everything, but then allow as well, just for the video side of the house. So certainly something that you have to look at. There's no prescriptive answer. You have to look at your environment and see what's going on.
Thanks, no, that's really good. And I grabbed this from the documentation where it says, hey, if you don't do the filtering rules, you may want to tell your users to not pick up the dropdown from the menu. And I think that's a situation most everybody wants to avoid. So, where's a great place to learn more? As you can see, we're trying to jam a lot into this hour, but we want to give people exposure as much as possible, this performance conversation. This remote desktop features and GPL document is fantastic. And specifically in here, you can see these pages for how to do the Horizon agent, ADMX template, and how to do the filtering rules to get that done. Moving forward quickly.
Steve?
Yes.
There was one question on RTEV, so maybe that's nice to answer before you move on. So do you guys know right off if TIN clients support RTEV now? I'm thinking in 0 clients, but that's my guess.
Yes, I think it's just a matter of the client operating system. So if we can get a little details, we can put that in the parking lot, since we have a lot of content to move forward with. And we can always do a follow-up if we need to. Chris, did you have anything to add to that?
No, I don't, but I'll look up while we're talking.
All right, perfect. I'm going to move forward because we still got a lot to go. We'll try not to go over, but if we do have to go over, you can always check the recording if you need to drop at the top of the hour. All right, so dictation. I wanted to touch upon this quickly because this also comes up. So just level setting, most of our customers are either using Dragon Medical One or DMO, as many people refer to it, or M-Modal Fluency Direct. And so how the scenarios will work is, with Nuance and Dragon, the microphone you're going to see is typically this Power Mic family. And then if you're an M-Modal customer of Fluency Direct, you've got this Philips speech mic. The thing to point out, and you're going to see a pattern emerging here, is number one, try to make sure you're avoiding USB to redirection on its own as much as possible. I think point two that we want to point out is, with this topic specifically, it's immensely important to work with Nuance and M-Modal to make sure you're working against their most current guidance, because it does change. But that being said, what looks best, especially in terms of Nuance, but this topic altogether, is if there is a specific optimization pack that will work with the clients that you have deployed, that should be your first option. And then something like RTAV would then be a fallback option. Now, I don't know that a lot of people know that this exists, but we have a public-facing KB article. Again, big shout out to Andrew Klopp, always helping the subject. There's 2 branches of guidance about Nuance and DMO, right? And he says here, so option 1, as we talk about, the USB split plus RTAV. So splitting out those buttons on the Power Mic, versus solution 2, which would be Nuance extensions which is where you're going to get the best performance. But the kicker right there, right, is you got to make sure that you've got a Windows client if you're going to go that route, right? Both will work. Both have been successful in the field. But again, it's, important. I spoke with Nuance yesterday. I got the most up-to-date versions of their documentation. Definitely work with the vendor if you have questions or if things don't look like they're working as best as you would like them to. Chris, again, this is such a
Yep.
place of
So-
visibility in the field. Anything you'd throw in there?
Before you plan any upgrade, this is a great point to make. Check with your vendors, check with Enmodal, check with Nuance, check with Imprivata. Make sure that you're on the same version of the software that they support, because those things are very fluid. They are tested, but there may be an upgrade in the other systems that you need to tackle at the same time.
That's a good point. Versioning, yes. Thank you for bringing that up. All right, as we move on. All right, so optimization packs for collaboration tools. This is something that once again comes up an awful lot, especially under this banner of remote experience. So Teams, WebEx, Zoom, probably the point of focus for a large part of this conversation. So we'll dive first into Teams and move on from there. So we'll look at Teams if you just used RTAV, right? And we'll draw this out, and hopefully the visuals will be helpful. So I've got the Horizon client on one side. I've got my webcam and my microphone. I've got my connection to the VM. And again, as we mentioned before, so because we're using RTAV, we're not doing full USB redirection, and we're instantiating this virtual webcam and microphone on the virtual machine. This can be VDI, it could be RDS. So we'll have Teams inside the VM. You'll note the resource requirements if we're going to do it this way, because again, there's going to be extra CPU processing. That VM will connect out to Teams, and voila, we're underway. And again, underscore, we have specific guidelines about if you're going to use RTAV with Teams in the virtual machine, about what your baseline should be. So let's look at the optimization pack. And so I'll call this out. I think this is widely known, but VMware develops and owns the optimization pack for Teams. Zoom and the Cisco packs, that's a different story, and we'll get to that. So let's draw this out. So now I've got the optimization pack. So again, I'm connecting to my virtual machine, could be VDI or an RDS host. I've got Teams inside that virtual machine with the Horizon agent. But instead of using RTAV, what we're going to do is we're going to have a virtual channel between the Horizon agent and the Horizon client. And what effectively is going to happen here is the Horizon agent is going to say, hey, I want you on the client to kick off the connection to Teams. I want you to handle the audio, the video, and the screen sharing. And I'm effectively going to get out of the way, and we're going to have a better path. And then resource consumption is going to get offloaded from me, the VM. It's going to move over to you, the Horizon client. Right? So this is, from a high level, a sketch of what the optimization pack with Teams would look like. So now, Christina Denike did a great blog. It's called out a little bit later in here, but she talks about, so we're reducing traffic out of the data center and usually improving the quality of the Teams calls for end users because of the path that we're taking. That blog is linked right there. So, well, specifically, if I'm asking, well, what's offloaded? So it's going to be the audio, the video, and the screen sharing. So that's moving now from scenario one, which is RTAV, into the VM with the Horizon agent. And now with the optimization pack, all that's happening over at the client. All right, so what are the savings again? So two, like we talked about. So network bandwidth, because we're not hairpinning, as you may, the way, depending on how you look at it, we're not going through the VM with the Horizon agent. And the server side CPU processing, so that we don't have to do the processing for the team section within the VM. It's going to happen over at the client there. So CPU demands within that VM will go down. All right, so what do we need to do to make sure I get this to work and it works right? So the good news on the client, it basically just works, right? So whether it's with the Windows client, the Mac client, the Linux client, you'll see here, it's ready to go with the default install. You don't need to do anything special. That will just work. So what about on the agent side? So once you've got the Horizon agent in place, that part is done. That part, quote unquote, just works, but there is one more piece, right? So as I called out here on the slide, so It's installed by default with the agent, but it's controlled with a GPO, which is not enabled by default. So you need to have this GPO in place, this ADMX file, get this value to enabled, and then you should be good to go and underway to use Teams optimization. Now, going through the documentation, I thought it was helpful to call this out, is that you want to make sure that you have the Horizon agent installed first before Teams. And I know no one wants to read a bunch of text in the slide, but what's going to happen is if Teams goes first, it's going to look around and go, oh, I'm not in a supported environment to run like an optimized optimization pack scenario. And it's going to cache. It's going to cache, what it sees the world to be on the first time it runs when it opens for the first time. So if you do get into this kind of scenario, install Teams first, you can basically blow away this folder, and then you should be good to go. But the big picture recommendation is get the Horizon agent installed before you install Teams.
And I have seen this in the real world, and it is maddening to try and understand why you're seeing an install every single time you launch Teams.
Well, good. Then I'm glad that I added it in there. So versions and clients, I think this is another thing where even I can only keep so much info in my head at one time. So breaking down what started working where, right? So at first, for VDI, Horizon 7.13, but also Horizon 8 with the 2006 release, those are initial support for Teams for VDI. So published apps / RDSH, right? So Horizon 8.1, 2012 and later, we're good with RDSH. But then it became, well, what about clients, right? Because the Windows clients were first. So Mac clients, if you have Mac clients, and if you're not on, the 2103 branch, so 2103 will introduce support for Teams with the Mac clients. And as you may surmise in healthcare, we got a lot of demand for, hey, when are you going to support this for Linux? So at 2106 is where the media optimization pack for Teams on Linux is supported. I found this really helpful as well. So this KB article, I took a tiny screenshot. It doesn't go well for screenshotting, but you can see here that this is the picture of continuous delivery, where you'll see between what Microsoft is delivering and what VMware is delivering with the optimization pack. Take a look at this KB article, and outside of support, quote unquote, for VDI, RDS, and the different clients, these different features and functions within Teams, you can map the client version that you're at with the capability in Teams and make sure that you're at where you want to be, or at least be able to project moving forward. We'll be able to, present these capabilities when we get to the next version. So in summary, and Chris, feel free to jump in, right? So, RTAB was how we did it at the beginning with that 4 CPU requirement until we got the optimization pack in place. It seems by far the best way to go about it for the reasons we described. Is there anything that I missed or anything that you would add in based on real world?
No, it's great. The philosophy is let the client do what the client's good at, what it's already doing. There's no reason to hairpin that up to the guest. If you think about it in that way, that describes a lot of what we're doing here.
Yeah. And just looking at the clock, we got a little bit to go. I'd hate to just kill the content that we have. So I think, I'll keep going, and we can timestamp the recording if you have to drop at the top of the hour. We're sorry we couldn't get everything in 60 minutes, but we'll get it in because we put a lot of effort into the content, and you can always come back and check the recording. But that being said, we'll go ahead with a good pace. So I threw this in here. If you want to, where can I learn more about Teams and how it's doing what it's doing? The TechZone article is fantastic. And Christina Denike did a really, really good job with her blog of describing, okay, what's the problem? What's the solution? And in a short amount of time, she gets really detailed into, well, how do you do what you do with the optimization pack? So I really recommend checking that out. So now Zoom, right? So the number one thing that's different about Zoom, and kind of alluded to it a little bit earlier, is Zoom is the one managing and owning the optimization pack in this case. It's not run and owned by VMware. But let's check out how it works, right? Because it's a little bit different, although it's very similar. So let's start again. I've got a client, person at endpoint. I've got the Horizon client, and I've got my microphone and my webcam. So I'm connected into my VM. Inside the VM, I'm going to have the Zoom client for VDI. That Zoom client for VDI is going to make a communications channel back to my endpoint device, where I have a second piece of software running, which is the Zoom Media plugin. And so what we're going to end up having, you'll see this in illustration in a second, the Zoom Media plugin It's going to make a connection to Zoom in the cloud. So we've got that direct connection between the client and Zoom, very much like what we saw with Teams. However, there's going to be a second stream and a second connection between the Zoom client for VDI and Zoom Cloud as well. So two differences here, right? Number one, Zoom maintains the pack, but they've been doing a fantastic job of developing new features for it. And their approach is slightly different. So we've got separate channels, as we said, between the client and the virtual machine. So, we just blew all that up in that illustration of what's happening here, right? So most of the media processing, in the words of Zoom from their own documentation, is being removed from the virtual machine. But the operative word here, obviously, most, all right? So we'll explain what that means. So the Zoom media plugin, that's what's sitting at the client, right? And that's what's doing most of the processing, as you would expect. So, and we've got these two data streams to bring about the overall user experience, right? The client and the virtual machine. So if I pivot my focus and zero in on the Zoom VDI client, like, well, what are you doing, right? So, okay, I'll tell you what I'm doing. I'm going to create an empty placeholder and a blank screen inside the VM, because the guy over there on the client is going to be the one connecting straight to Zoom. However, the Zoom VDI client's still doing the meeting toolbar buttons, and we're going to maintain the participant list, and I'm going to process any kind of screen sharing, so to speak. The media plugin is the one, as you'd imagine, it's going to connect directly to Zoom. I'm going to handle the video, the audio, the content. I'm going to layer the image in the Horizon client on top of that blank screen that's sitting, if you looked, and remoted right into the virtual machine itself. Key piece being that the virtual machine and the plugin are going to work together, because we've effectively got these two layers working in sync, right? So certain things being done on the virtual machine, most of the things being done on the client, and they're working together to provide the end user experience. That's the net. A couple of things I'll point out. Client support is extremely good for the Zoom optimization pack, if you're not familiar with it. This I want to show because when we worked with a customer of ours in Massachusetts in spring of 2020, when people were being sent home en masse, I think the number of video participants might have been 10 at one point, and then they got up to 25. I refreshed it in the last couple of months. It's now 49. So they've done a really good job of continuously developing for this. And if you're like, hey, I'm just getting started, interested in this, here is the link to that document. So you can ask us for a PDF copy of this section of the pre's. They'll be happy to share it. I know that we had said we're only going to talk about things around the truck, but there is something of a pain point here with these third-party optimization packs, and that some customers have said, hey, we don't always control the clients, and so we can't always control if the optimization packs are in place. So this is not a promise of delivery, but this is something that I've been told in good faith is going to come in the not too distant future, maybe next spring, maybe a little bit earlier. So what's going to happen is we're going to use the Unified Access Gateway to do a function that's similar to what we do with OpSWAT and Sentry Bay, where we can place the latest version of the optimization packs, the Zoom optimization, the Cisco optimization packs, on the UAG. And then at the time that the Horizon client makes that initial connection, it can check to see if there's a newer version of the optimization packs that it should know about, and then it can then pull it down to that client. So again, not an outright assurance. This hasn't been delivered yet, but speaking with the PMs, they said it was okay to share. This is something that is slated for delivery in the not too distant future. So we're almost to the end of this part of the session, but for what's left, we really did a lot of time actually talking about this part of the presentation. We'll get it back to Hilco and we'll lay on the plane. But what about things that aren't Zoom, that aren't Teams? What about straight URLs or web content, right? And so did this diagram for the status quo, so to speak, or from just launching URLs within the VM, within the data center, right? It's going to look something like this, where I start from the client, I get into the data center, I get to my VM with the Horizon agent, and then depending how you look at it, it's kind of like a hairpin, depending on where I am to ultimately get to that website. So another way to do this, and we'll show a couple, and then we'll do the GPO and we'll be done. Number one solution that we've talked about a lot in the field in the last couple of years is called URL content redirection. So the overly simplistic way of looking at this is instead of everything launching from the VM and the data center via the Horizon agent, I launch that URL from the Horizon client and go direct to that website and get a better path and again, less resource utilization. Here's a little bit more detail about how URL content redirection actually works, where we're going to need to add in this URL content redirection helper on the endpoint on top of the Horizon client. And then over on the Horizon agent side, there's a group policy that's going to say, hey, these are URLs where we want to do agent to client redirection, and we want the client endpoint to launch these as opposed to within the Horizon agent. And so we will launch, we will utilize the client at the physical endpoint to get to that website. The key piece is we're going to invoke a browser that's on that local endpoint. We're not going to do it within the Horizon client itself. So some people may really like that. Some people may wish to go a different route. So we're going to explain that in the next minute or two, and then we'll do the GPU and it'll be done. So just for URL content redirection, there are two workflows, right? So we've got what's called agent to client, which is what we'll be talking about for the purposes of this discussion, where we don't want URLs or websites being launched within the VM. And then there's client to agent, which is more of a corner case, at least with regards to this discussion. So there are benefits, right? So the network, CPU, the compute resources are going to move from the agent VM to the endpoint. And so there's definitely going to be performance benefits. And I put here on the bottom is actually commentary provided to me from one of the PMs who feels like, this is something worth considering if you're a customer. Now, in terms of, what we're doing, right? So we move compute, we optimize the path, and we're launching the URL and the endpoint. And Chris, maybe, I know we got to wrap this up, but maybe, you and I talked about this with Hilco. There's a user experience thing to point out here that may or may not be a reason why someone may want to do this. Do you want to share your thoughts?
Yeah, so I was going to give the example, right? Everyone here has probably heard of Epic or is living the Epic life every day. One of the real world use cases for this that I've seen quite often are YouTube training videos attached to Epic. They might build it into the help menu inside of your Epic client. Why would you want to run those YouTube videos inside of your Horizon session when you could pass it down to the client? That takes a lot of workload off of those RDSH sessions and helps distribute it out and lets the end user have a little bit better experience as well.
Yeah. And so in terms of terminology, this is what we call client fetch and client render with this whole umbrella topic where we're moving things to the client. It's just a matter of, will your users be bothered by this fact that we're going to invoke a browser? I'm calling out Chrome in the diagram, but we're going to invoke a browser on that endpoint and not do it within the Horizon client itself. But it does support this approach. This works with Windows, Mac, and Linux. You're going to need the Horizon client for each of the workflows, and just calling out, well, which browser would work if I did want to do this. So here's what's supported on Windows, here's what's supported on Mac, and then you can see here's what's on Linux as well. I know.
And for RDSH users, right, they're already expecting a pop-up with a browser to view that in. It just happens that in this case, that browser session is running locally, not in the Horizon session. So it's a little bit less intrusive as an RDSH application.
That's a really good point. And so lastly, I'm going to turn over to Hilco, but if you did want to do this, just calling this out, you do have to do a manual command line, install the Horizon agent with a switch, captured it in the lab right there. And similar for now with the Horizon client, where you would need to do this switch with the URL filtering enabled. So there is some extra detail to get into. So I'd recommend, checking out the documentation. And so with this, I'll hand it back to Hilco and we can land the plane, but going back to where we started, right? So if you're like, I don't know if I want to see that user pop up, but going back to, getting a URL with a quote unquote anywhere user, is there another way we can do client fetch and client render as opposed to this server side? There is, and I'll hand it back to Hilco, and if he's still here.
Oh, I'm still here.
All right, great, thank you. Let me know if you're okay to share your screen again. And
I'm trying. Just give me a couple seconds.
Yeah. So what we're going to get into is another option called browser redirection, which I think, based on conversations with a lot of our customers, what browser redirection provides may be what they were expecting with URL content redirection. Maybe, maybe not. There you go. All right, I think you're coming up now.
Yeah.
Awesome.
Okay. So yeah, one other option that we have is called HTML5 multimedia redirection. And what we do there is that we take anything that has an HTML5 media tag and we simply send the bits of that over to the client and we render it on top in a visible, invisible window over it. So here the agent is still fetching the actual bits. So even if you would have clients that have no internet access, but your VDI has, it's still able to send it through, but it's being rendered on the client. And just think about the amount of things that this saves, right? Because the agent no longer has to decode the video and it doesn't have to render the video. And then we don't have to grab the frames and then re-encode them and send those over the line. We just take the bits that are incoming and send those out. Then the other thing we have is called browser content redirection. And what we do here is that the whole viewport of the browser is being redirected. And this also avoids hairpinning, but then the agent does all of the fetching. So when we compare those three features, so the one that Steve just described into detail, the URL content redirection with HTML5 multimedia redirection and browser content redirection, is actually what happens, right? So with URL content redirection, it is a browser that's being opened and it is getting the URL to open either on the client or on the agent side. With HTML5 redirection, it's the agent fetching the bits, the client rendering them. And with browser content redirection, it's not that different from URL content redirection, but the big difference is that it's in an invisible overlay and not in an external browser. And there are different supported clients and supported browsers between those components. So then GPU. So one thing we get asked a lot is, do I need a GPU? And my main response to that usually is, well, what are you doing with it? Because there seems to be a perception that everything runs better with a GPU and that you're saving CPU cycles with a GPU. Now, what I did here is I did a couple of benchmarks with different codecs, and I did them with and without a GPU when possible. And what you see on the left is the number of megahertz that it took. And this is a knowledge worker. It's not doing something fancy. But what we see here is that with no GPU, I'm using roughly 800 megahertz for most of them. And then with a GPU, that bumps up to 900. So where did that 100 megahertz go? Well, the GPU has a frame buffer and the GPU is doing things and something is feeding the GPU, and that is the CPU. So it actually takes CPU cycles to feed the GPU. Now, if the GPU is doing something very useful, like doing, say, CAD work or encoding videos or doing something else, you gain more than that back. But when you're not, when you're looking at 2D things, it's not really doing something. And then what we did in this testing is that we did disable the animations in Office. We did disable the Windows animations, but is it actually worth having those animations? Do your users care? So that is something to think about. Now, if you have an application that's being accelerated by a GPU or it needs a GPU just to have enough frames, like doing CAD or anything like that, then yes, use a GPU. When you don't, maybe it's better to spend the money in extra hosts than in GPUs and licenses. Then quickly about protocols, because people also ask a lot, which protocol should I be choosing? Now, that highly depends on your use case, and all of the protocols are different. So when we look at this diagram, in the middle, you see native. Unfortunately, you guys have the Zoom compression on top, so you just have to believe what my eyes are telling you. But the native one looks absolutely identical in my eyes to the BLAST PNG beneath it and the BLAST codec. Does that mean that they are all lossless? No, they're not. So the BLAST codec is actually being optimized to be roughly 80% of the quality of lossless. But the human eye also is only capable of seeing that amount of detail. So in my eyes, the BLAST codec is as good as lossless. If you're doing something medical and it really, really matters and it needs to be absolutely lossless, then BLAST PNG would be your choice. Then for BLAST H.264 and even H.265, the thing that matters most there is it's really good when you have high frame rate content. So when you're watching video or when you're doing simulations or doing CAD, when you have many frames following each other, it nails basically everything. But when you have standing still images, it is not that great, especially at the default quality. When you have a GPU, we've got hardware encoding, it's even a little bit worse. Now you can bump up the settings and get pretty close to the BLAST codec, but then you're getting an overhead in your bandwidth. So here's what I've did. I've tried to benchmark as much as I could from all of those codecs and played around with those settings. So we've got the BLAST codec, we have the BLAST codec with the GPU, or H.264, H.264 with GPU, JPEG PNG, and I measured the CPU usage, the image quality, the bandwidth, the latency with a click-to-photon device, and the frames per second. And then I gave those a score between 1 and 10. And if you look at the diagram on the left, it's like one big pile, and it doesn't really have something that stands out. But if you go to the right, what I did there is that I weighted the scores. So for this use case, a normal knowledge worker, or maybe somebody behind a desk or in a hospital, for me personally, the quality matters most, and it matters more than the CPU usage. And then the CPU usage is more important than the bandwidth, and the bandwidth is more important than the latency, and the latency is more important than the FPS. And if I weight it like that, you can see that the BLAST codec in there would be the absolute winner for this use case. Now, if you're a 3D worker doing CAD work or something else, everything shifts, because then FPS might be most important, then latency, so the whole order changes. So you need to be thinking about what you're doing. But in general, I would say for everybody doing office kind of work, it's probably the BLAST codec. For everybody doing any kind of 3D kind of work or video, it's going to be the BLAST H.264 codec. And for anybody who is doing medical things, it's going to be BLAST PNG. So Steve, do you want to do anything on this slide? Did we lose Steve?
You're on mute, Steve.
Thank you, sir. All right. So maybe we could have done this at the beginning, but we wanted to give the content first. So if no one listens to this on a recording or people are still here, if you would be interested in providing your feedback direct via the Q&A, we were really curious about if you're still at 713 and working to get off on that and going to 2111, or are you already there? Is everything good? Or maybe do you even operate outside of an ESB release train? We're trying to figure out if people need help and guidance with getting to 2111 or beyond or whatnot. So it's more of an art than science figuring that out. But if you feel like sharing that, that'd be awesome. And then the other question I had, if you wanted to give some feedback via the Q&A, is if any of these topics specifically would be helpful or of interest for a follow-up webinar, whether it's an hour dedicated exclusively to double hop nested mode, something just on Horizon upgrades. We've talked about doing that. And then maybe, an app volumes, performance, best practices, or something with DEM and the ways that it's used best within healthcare. So if you have any thoughts or opinions, or, if you're watching this on the recording, want to reach out to us directly, you can totally do that as well. But these are things we're kind of wondering about and hoping to better understand. And so in terms of where to learn more for the OS optimization tool, there are 3 really good articles and resources on our VMware UC Tech Zone. So the links are included there. I went back and reread everything before doing the webinar. I thought it was really helpful as a refresh. Also, a great article that the team did on hardware accelerated graphics with Horizon. Don't let the Horizon 7 don't let that dissuade you. Extremely good article, really, really helpful. And then last but not least, as we mentioned in the beginning, we have this, digital workspace and healthcare channel that my boss created and manages, Mr. Rick Falsey. So we will get this uploaded to that site probably next week. So this will be available for recording and playback, as well as all of the other webinars that we've done in the past. So as we look to wrap, number one, I want to thank you, Hilco. Hilco is in the Netherlands. He's 6 hours ahead of us. He did this on his own time and volunteered to help us out. So Hilco, great job, and really thank you so much for all this content. This is fantastic.
Anytime, Steve.
Yeah, I feel like we have a new gold image that we can refer back to. And Chris, any thoughts or anything we might have left out that we should have called out during the course of the hour?
Yeah, so my closing thoughts here, and this is the soapbox that I get on, is if you're a Horizon admin, if you're a Horizon architect and you're working in healthcare, you must have a UAT environment. All of these optimizations are very iterative processes. So you will be doing a lot of testing, and that testing should be done in a controlled environment. One of the things that made me successful as a customer was having a UAT environment that I could bring in providers, nurses, knowledge workers, and have them beat up a system and put it through its paces without affecting production. So are you heading in the right direction, or did you make the experience worse? Having that UAT environment is the key to success.
Here, here.
There is one more question in the chat. So trying to figure out how to get off trim print for pass-through. How much testing will be needed to move to virtual printing? So I'm thinking we're talking about VMware integrated printing.
Yeah.
The features that they have are very, very similar. So I find the transition to be quite easy. And that's my personal experience, and it works really, really well. So I've had very, very little problems with it. Did you guys see any problems with moving into VMware integrated printing?
I have not. I know, Sean, have you seen anything? I think this is something you've been working on recently. I don't mean to call you out from the chat monitoring duty.
Yeah, so it seems to, just like Hilco just said, it does seem to work very similar to how ThinPrint is working. We are working with another large customer on some scenarios where we have a bit of a challenge, but we are working at it. And actually, we're using Deem to actually solve that problem in addition to the integrated printing. So there's some good plugins there.
Then there's another one from Brian. Will your team be covering storage for VHD for non-persistent desktops? Are you talking about FS Logics there, or are you talking about app volumes in combination with Horizon Cloud for VHDs? Brian. You can do it in the chat, or you can do it in Q&A. If you're still there, maybe you've dropped.
I do note the feedback we've gotten that a lot of people would like to see an app volumes and DEM session. So we'll take that into consideration, see if we can put something together.
Okay, talking about backend infrastructure, seen a bad option getting picked. Okay, so there's brand options as well. So we do not make any kind of hardware recommendations normally. What I would say is, in general, I personally prefer using Windows servers as VMs for the storage. And what you put behind that, there's various choices and various options there. I think vSAN works reasonably well, as long as you stay out of the vSAN file services and just do it with a Windows VM. And then whenever you're doing something like FS Logics, then make sure that you use REFS as the file system, because the VHDX files just work better on that. I think those were all the questions.
All right, sounds good. We really appreciate all the customers that stayed the extra time. We do try to get everything in an hour, but I think you saw we had the content. We didn't want to skip it. So appreciate everyone who was able to hang in live and everyone who check this out over the recording. So this will be posted soon. We'll probably do another webinar or two before the year is out. We'll be in touch with regarding that. So for now, if you have any direct questions as a result of this session, definitely feel free to reach out to myself or Chris. Thank you again, Hilco, and have a great rest of your day, everybody. We appreciate your time.
Bye all.
Take care.